Yeah, thank you, Satya. So just for the last 2 days, there is discussion regarding shear strength parameters. Okay. So generally tailings or whatever the material, if it is soil like we are considering, maybe fly ash. So big discussion regarding this cohesion and friction angle, because these are the two parameters that is contributing towards the shear strength of a particular material. So when we are considering the shear strength parameters, the cohesion or friction angle, these are not the inherent properties of the material. Okay, that depends upon various factors. So what is the test condition, whether you are doing direct shear test or triaxial test. Then if you are doing triaxial test, then what are the test conditions? Okay, so whether we are doing the test under unconsolidated undrained, consolidated undrained or consolidated drain, clear. Then this also depends upon what is your type of means say during that loading condition, what is the drainage condition. Next part is what is the degree of saturation of the soil. Third condition is the rate of loading. These are the three factors that affects the shear strength parameters of a material. Then for that particular soil, if you are collecting at 1 meter or 2 meter depth below the ground surface, the same soil will have a different value of cohesion and friction angle. That is not constant. Okay, that depends upon. That's why we cannot say that this for this particular soil at this location, its cohesion or friction is not constant. Next depends upon what is our purpose. For what purpose generally we are finding out or determining this cohesion and friction angle. Okay. So further briefly I will give you some idea. So this generally we are using this triaxial test setup. Okay. So this is a typical schematic diagram that shows the triaxial test setup. So there are, you can see. Next part is, then we are saying one thing, that clay type soil, silt, sand and gravel. Okay. So this is one general idea. Everyone is thinking that it is sandy type soil. So cohesion cannot be zero. Means phi cannot be zero. But we will get phi equal to 0. Even if it is sand, now during when do the test, we will get phi equal to 0. And also if it is clay type soil, again also we will get C equal to 0. So what is that condition? Okay. So for that, this test of setups, if you see, so there is one soil sample. Okay. So we are applying first is the confining stress. So it's important. What is its significance? Because if you are collecting one soil sample for 5 meter depth below the ground surface, it is in a confined stage. To simulate that, we are applying some pressure. That is in terms of water pressure. Okay. So there are 3 pipes are connected. One pipe is connected to the center of the soil. Okay. That is connected to pore pressure measurement. Clear. Then one more is drainage burette. Okay. And third is for applying the cell pressure. And this cell pressure we are applying 50 kPa, 100 kPa, 150 kPa or 200 kPa. Okay. That depending upon our requirement. Next, this part, first I will say, this is the, when you will do this test, there are 2 stages. One is the application of cell pressure, second is the application of debit during stress. Okay. So when you will say cell pressure, that is we are applying, it is equal in all directions because water pressure. That's why I have written pressure in the second case I am written it is stress. So difference. Okay. Pressure means it is acting equally in all directions. Stress only in vertical direction it is increasing. Clear. Now in a lateral direction that remains constant. Clear. So first I will discuss. Just I have drawn a few by hand that unconsolidated undrained condition. Okay. Then when we are determining this C and phi, that is based on the Mohr stress circle concept. Okay. So we need 2 stresses. One is sigma 3, that is the minor principal stress that we are confining pressure whatever we are applying, and second is the that principal stress sigma 1 that is acting in the vertical direction. Okay, then that the difference is the, we are saying, deviatoric stress. Okay, so now in this case, if you see, now the soil is two conditions I am going to discuss. One is soil is fully saturated. Another condition is soil is partially saturated. Clear? So if you see soil is fully saturated, all voids are filled up with water. Clear? Whether it is sand or whether it is clay, irrespective of the soil. Now first you apply the confined pressure. Then we are saying what? Unconsolidated, undrained. Okay. So that depends upon our drainage condition. Achha, one is unconsolidated, other is consolidated. Now that consolidation or unconsolidation, that we are simulating in the first stage of the loading. That first stage of loading is the confined pressure. So we will apply that confined pressure. Now after application of this confined pressure, what we will do? We will close that drainage valve. Clear? And the soil is fully saturated. Once you will apply this confined pressure, what will happen? There will be rise in the water level in the pore pressure tube. Okay. So if it is fully saturated soil, what will happen? Now all load immediately. Now it is closed. Okay. The drainage valve is closed. Now we are applying the confined pressure. It is filled with water. Now water cannot be drained out. So when we are applying force, or if it is not drained out, what will happen? That load will be carried by the water. So whatever the magnitude of we are applying confined pressure, equal amount will be measured in the pore pressure. Means solid particles or soil particles is not carrying any load. All load will be carried by the water. Clear? So equal amount will be measuring in the pore pressure measurement. Clear? Now if I open the valve, what will happen? Then water will start flowing. It will be drained out. Then what will happen? That pore water pressure that will gradually decrease. Clear? When there it is decreasing, then there will be change in volume will occur, because volume of voids will decrease. And we know when there is a change in volume, there is that indicates the consolidation. That means that it is a consolidation. Main we are saying it is the dissipation of excess pore water pressure. Means whatever the pore water pressure that we measure in the system, now that is gradually decreasing with time, and there is a volume is decreasing. Clear? In the meantime, there will be change in effective stress, because initially the total soil mass with that saturated soil that is subjected to confined stress sigma 3. Clear? Now in that time, now pore water pressure is there. Clear? So pore water pressure initially it is equal to same amount if it is fully saturated. So effective stress it will be very negligible. Now when water is drained out, there is a decrease in the pore water pressure. So effective stress is a total stress minus pore water pressure. So effective stress will gradually increase if we are doing the consolidation. But we are not doing consolidation in the first case, that is the UU case. Clear? So since we are not doing, now see there are 3 regular circles and only one dashed circle. Clear? That dashed circle is the effective stress circle, and all these regular circles of dark line, those are the corresponding to total stress. Okay. Suppose first circle, their confined pressure sigma 3 is 50 kPa, second is 100 kPa, third is 150 kPa. Now we have applied no consolidation. Then we are applying the deviatoric stress. Now gradually we are applying the deviatoric stress. So in the first case, what will happen? Suppose failure occurs at a particular magnitude of a deviatoric stress, 30 kPa or like something. Yeah. Then now whatever the load you are applying, now solid particles are not carrying any load. All load will be carried by the water. Then what will happen? A stage will come. So there water will have some resistance. Now that will try to fracture the soil. Clear? That failure occurs. Clear? So during that time, now there is this cohesion. That is what we are saying. That is the bonding between the particles. And friction, that is due to rolling or sliding between the particles, or it may be combination of a rolling and the sliding. Clear. Since solid particles are not taking in load, now whatever pore water pressure developed, due to that now failure occurred. Clear. That is at a particular confined pressure. Now we are increasing the confined pressure to 100 kPa. No drainage, nothing. So equal amount of same amount of excess pore water pressure is developed. Clear. That means in all three cases, now what happens in there is in proportionally that a deviatoric stress is increasing. That's why in all three cases, what you will get that the deviatoric stress remains constant. Your sigma 3 is 50, 100, 150. Sigma 1 is increasing. Clear. But that difference, sigma 1 minus sigma 3 for all three soil samples remains constant. That means I will get the diameter of all these three most stress circle remains same. Now how will get C and phi? By drawing tangent to all three circles. So we'll get one more or less a horizontal line. If it is a horizontal, then what I can say? Phi 0. Yeah. Only I will get C. So that we are saying the undrained cohesion of the soil mass. So even if it's sand, it is fully saturated, there is no air voids, we'll get that phi will be 0. Clear? So that is the basic part. Now the same test, UU test, will do for the partial saturated soil. In partial saturated soil, air is there. Clear? So we are applying confined pressure. Clear? There will some air is compressible, some decrease in volume will come. Then again we are applying the deviatoric stress. But drainage, there is no draining out of water. Whatever change in volume coming, that is due to the compression of air. So their change in volume occurs. That's why we are getting different value of effect. Means our pore water pressure will be different. Means some load will be carried by the solid particles, some load will be carried by the water particles. Clear?
But sir, in previous case, why some load will not be carried by solid particles when we are not allowing the drainage?
Yeah.
In the first case, why
just simple example.
Why it will be taken only by water? Because solid particles are also there, sir.
Yeah. Just simple example. You take one bowl. Okay. You keep some spring inside the bowl. Fill it with water. On the top you put on a lid. Clear?
On the top?
You put one lid cover. Okay. Now it will be in supported condition. Water and spring is supporting. Clear? Now put one load, small load. Clear? What will observe? If there is no draining out of water, if water is not coming out, what will happen? Spring will not differ. Clear? If spring is not deforming, what it indicates? That means spring is not taking any load.
Correct.
All load is carried by water.
Okay.
Clear? Now when water is coming out, then what happens? Spring will compress. Now spring is carrying the load. That is the mechanics behind it.
Okay. So in the first case, spring
so
is
in
equal to soil particles.
Yes. Now in first case, this spring is the solid particles. Okay. So there is no change in volume. That means the load is carried by the water.
Okay.
That's why whether it is sand or whether it is clay, it does not matter. Load will be carried by the water.
But if whatever the load is carried by the water and if we apply higher load than that, in that case what will happen?
Which one? No, because before that
there will be some limiting capacity of the water.
Before that
the
load, inside there will be hydrofracture. Because when water pressure will exceed certain limit, what will it will try to do? It will fracture the material. That is the failure case.
So like whatever the load water can carry maximum, if we apply higher pressure than that, soil sample will fail. That's what you are saying.
Which one? No.
In the first case, sir.
Now because now what will happen? That if you are applying higher pressure, that soil is
if you apply higher pressure, entire load will be taken by water only.
Yes.
No soil particles.
Yes.
Further I increase the pressure.
Because you see, water is not compressible. Water is not compressible. To compress it, you have to need very high value, and that our machines are designed for up to certain range within the solid particles.
Okay.
Clear?
Okay. So only water will be taking the load.
Only water. If it is undrained condition.
Even if we increase the pressure, then also it will be taken by water only.
All water will be taken.
All load will be taken by
Once
water.
water starts draining out, then stress will be transferred from the
Water
water
to
to
soil
soil particles. That is the mechanics. Clear? That's why we are saying whether it is sand or clay, it does not matter. So our phi will be 0. Clear?
Partially saturated, some voids are filled with air and some are filled with.
Water.
Water.
Clear? And the air is compressible.
If we don't allow water to pass, get out from this air, and where we allow this air to pass from this triangle.
Because now see that membrane is there. Okay. Then this porous stone is there. Clear? So some water will be, some air that will be compressed. Because air is compressible in material. Clear? So now that air, once it is at stress compressed, that position then water particle will move. Then when there is a compression in the air volume is decreasing, now water is trying to, their internal movement of particles, means water will try to fill up those air voids. Clear? So that's why you see now second figure. This is for partial saturated soil. Now you see 3 circles, they are having different diameters. Clear? And one more thing, so when these lab people they are determining this C and phi, most of the times they are using 2 circles. That is the mistake. Because if you do 2 circles, we will get a well-defined tangent. But if there are 3 circles, we cannot get a well-defined tangent. That line will be curved line. Clear? That's why we are making a best fit line to touch all these 3 circles. So that is the condition. Okay. So that's why in that case what we will get, now these are suppose 3 total stress circles. Similarly we will get 3 effective stress circles. So from there we will get total stress parameters and effective stress parameters. Clear? And this I have shown that if degree of saturation is less than 100%, degree of saturation is equal to 100%. If I do the test any sample, then that line will be horizontal, otherwise that line tangent that will be inclined. That will give you both C and phi. That's why in UU test, if you are getting both C and phi, that means it indicates the soil is partially saturated. And if you are getting phi 0, it indicates the soil is fully saturated.
So sir, for this any of the structure, where we find out the bearing capacity based on this Terzaghi formula. So what condition we should consider to?
I will come next CU and CD. Okay, just prior. Now we are saying tailings.
No, I am not talking about tailing.
Just one example, then I will go to that.
Yeah.
Why it is important that undrained shear strength. This undrained shear strength is the undrained cohesion of the soil. Because our tau shear strength is C plus sigma tan
Sigma.
phi 0.
Correct.
So our shear strength is dependent
C.
upon undrained
Directly
cohesion.
C.
Clear?
Yeah.
So now in tailings, why we are using this undrained cohesion? Achha, that comes from this UU condition. Tailings, it takes lots of time for consolidation. Always tailings will be in unconsolidated stage.
Okay.
Clear?
But what is the reason? That means why we are considering tailing as unconsolidated and
Yes, because why we are considering, because that tailings are gradually settling.
yes,
There is change in volume is occurring.
yes.
Clear? It will take 100 years or 200 years. Clear? So what, when we are doing the design, immediately you will put the tailings.
Okay.
So we have to consider what is the initial stability. Because now we have applied after 1 month whether it will be stable or not. But within 1 month it is in unconsolidated stage. So whatever its strength, that should be corresponding to the unconsolidated state. What the idea means? And second thing, now in this case, this test will take about 15 to 20 minutes. Because we will apply the load at a very high rate. Clear? So that's why we are saying it is a very quick test. Another thing I am saying, now sand in the field, if you are saying, okay, suppose now sand is there and in field concern, and suppose there we are doing some this blast. Clear? So water is, it is submerged condition. Blast is very fraction of second. within fraction of second, what will happen? High amount of pressure will be developed in the soil mass, and that water cannot be drained out. That means now what I have to consider, it's undrained strength. Because now phi has no role, it cannot contribute any strength to the soil. Whatever strength that will be contributed by the cohesion of the soil mass. Clear? Next comes the, I will come to your question at
Yeah.
the first level.
Yeah.
Next comes the consolidated on-drain test. Okay, in consolidated on-drain test, first we will do the consolidation of the soil mass. Okay, so this is one typical figure left side, void ratio versus pressure. We are increasing, so void ratio will decrease. Then there is a point about 900 kPa. Okay, from there then it is unloading we are doing. Then there is back. Okay, so now one is our whether the soil is normal consolidated or whether the soil is over consolidated. Now I have loaded the soil up to 900 kPa. That means I am applying confining pressure up to 900 kPa. Clear? Then with 900 kPa now I will open the drainage valve. It will get consolidated. There will be decrease in volume. Clear? Now I got after 2 days or 3 days, it will take even 7 days for draining out of all water. Okay. Now that our deformation remains constant. That means it indicates the soil is fully consolidated. Now with that 900 kPa, now you apply the deviatoric stress. Clear? When you are applying the deviatoric stress, what will happen? Then when you are applying deviatoric stress, then we are considering what? On-drain condition. Consolidated, on-drained. First stage is consolidation. Consolidation is due to application of a confined pressure. Now consolidation is over. Then we will close the drainage valve. Now I will apply the vertical load in the vertical direction. Then it will increase. When it will increase, now what will happen? Same thing. It is in fully saturated condition. Voids are filled with water. Clear? Then water load will be carried by the particles, water voids. Then after certain time failure will occur. Clear? This is 900 kPa. Then now I am applying confining pressure, suppose 600 kPa. Then I have done the consolidation. Clear? Then I again read the test. Clear? Then in this case what will happen? We will get 3 different circles. Diameter will be different. Now question will come. In a previous test, it was on-drain condition during application of a deviatoric stress. In this case also, during application of a deviatoric stress, it is on-drain condition. But why we are getting 3 different diameter of circles? Because in first stage, we have allowed the consolidation. So the degree of a deformation in the first sample at 900 kPa and the amount of deformation in the second sample at 600 kPa. The amount of deformation in third sample at 200 kPa is different.
Means 2 different straight line for 2 different stages. Actually.
Yes. Okay. So that means at 200 kPa already it is consolidated. At 400 kPa it is consolidated. At 600 kPa it is consolidated. That means whatever the soil that is consolidated at 200 kPa, it will have a less resistance compared to what is the soil consolidated at 900 kPa. That's why when we are applying the deviatoric stress, that we are getting higher deviatoric stress for the soil which is consolidated at 900 kPa. Clear? So that's why you will get 3 circles of 3 different diameters. Clear? Then we will get similarly 3 different effective stress circle, because pore water pressure development will be different. Clear? Because in the second stage now our pore water pressure is different. That's why we are getting 3 different circles. Now this I discussed normal consolidated clay. Same clay. In one condition we are saying normal consolidated, in other condition I am saying it is over consolidated. So in a normal consolidated clay, now you draw the tangent. What will happen? That a tangent will pass through the origin. What we said? It is clay. It is clay. Fine particles. There is a bonding. But from the results, what we are getting?
C0.
C0. Clear? Why C is 0? That I will discuss after few slides. Okay. Next, I will discuss over consolidated soil. Over consolidated soil means now what I am doing, I have applied confined pressure 900 kPa. I consolidated the soil at a 900 kPa. Then what will do? Unloading. Now I am removing that consolidation is there. Clear? Now what will happen? That drainage valve will be closed. Now that shell pressure I am decreasing. From 600 kPa I reduce to 800 kPa or 600 kPa. Already it has subjected to 900 kPa. But I reduced it to 600 kPa.
Both the condition valve is closed only.
Yeah. Remains closed. Okay. Only because that state of soil should sell. State of soil should sell. Only I am changing the confined pressure. Clear? So after removing this to 600 kPa, now I will do the test. Now the soil is in over consolidated because earlier it has subjected 900 kPa. The current state is in 600 kPa. So over consolidation ratio, that is 900 divided by 600 kPa, 1.5. Clear? So now I will do the test. Clear? When I will do the test, then what I will get? I will get one deviatoric stress. Now I will another sample. I have consolidated to 900 kPa. I reduced it to 300 kPa. Now over consolidation ratio is 3. From 300 kPa, now I will start the test. Clear? Then what will happen? I will get another deviatoric stress. That will be less than that point. Then I will reduce it to 100 kPa like that. Clear? So there I have shown over consolidation ratio I have written for different condition. Okay. So for that we are getting different circles. Clear? Now in this case over consolidated soil, you see when you draw the tangent, we will get both cohesion intercept and phi. Clear? Achha. One more thing. In previous case, in this case, effective stress circle is on the left side of the total stress circle. That means what it indicates? Effective stress is less than the total stress. Total effective stress equal to total stress minus effective stress. That means that pore water pressure is positive. Clear? But when it is over consolidated soil, that pore water pressure will get negative. There will be suction. Means now what we are considering that pore pressure measurement pi. Clear? This is the level. So in normal consolidation soil, from the normal level it is above, positive pore water pressure. When it is over consolidation soil, we get below it. This is our negative pressure. Some suction is developed inside that soil. So that's why you will see that the effective stress circle in some cases you will see that is the right side of the regular circle. What the behavior, how it is changing depending upon our over consolidation ratio. So that also affects our shear strength parameters C and phi. Next, this part, pore pressure development in the right side also. Okay, so because generally we are considering this is loose sand behavior is similar to normal consolidated clay, and this dense sand behavior is similar to our over consolidated clay. So you see any loose sand or that if I consider normal consolidated clay, you will get positive pore water pressure from the beginning. You see upper side is positive, lower side is negative. If it's a over consolidated clay or it is a dense sand, initially there will be positive pore water pressure. Why that happens? Because when we are applying the force, okay, so the particles or water cannot move out. Okay. Since water is not able to move out from that soil particle, so what will happen? They will try to, soil particles are there, clear. Now they will try to pull the particles, but they are not able. What the point? Now there are two particles are there, inside water is there. So when we are applying load, all load is carried by the water. Now water will have a tendency to find the path, but already drainage path is closed. So what will happen? They will try to move, but water is not able to move. That means those particles, that water in between those two particles, those water will try to tends to force some these particles, but able to, and particles cannot move because it is confined. So these particles will give positive pore water pressure in case of a normal consolidated clay. In over consolidated clay, it is opposite. Clear? What will happen in that case? That water, okay, that tension is developed. Clear? That particles, what will happen? They will try to move away from each other. Then tension will be developed. That's why negative pore water pressure is developed. If it is a tension of the over consolidated. Now consolidated drain test. Okay, in consolidation drain test, what happen? First we are consolidating, drainage is open. Second stage, when we are applying the deviatoric stress, drainage valve is open. Clear? Now this test generally takes about 1 month. One sample will take 1 month. To saturate the sample, it will take minimum 4-5 days. To consolidation, it will take 1 week. Then for application of a deviatoric stress up to failure, it will take 10 days. Why? Now see, in UU test, suppose we are applying 100 kPa deviatoric stress. What will happen? We will apply at 10 kPa per minute. Within 10 minutes, test will finish. In consolidated drain test, I will apply 0.1 kPa per minute. Why? Means to simulate the field condition. Means if I apply 0.1 kPa, what will be pore water pressure development? 0.1 kPa if it is undrained, if water is not dissipated, it is 0.1 kPa. 0.1 kPa is very negligible amount. That will not cause any harm to the soil. So gradually we are applying 0.1 in every 1 minute. So there will be no development of a pore water pressure throughout the test. There is no chance of a death. Means water is gradually draining out, but there is no development of a pore water pressure. Why? Because our rate of loading is very less. Clear? That's why it is we are saying consolidated drain test. That's why whether it is a total stress or whether it is effective stress, both is same. We will get only one parameter, total stress or effective stress. But in CU test, you will get total stress parameter, effective stress parameter. In UU, we will get only total stress parameter because we cannot draw effective stress circles. In this case also, during application of a deviatoric stress, it is undrained condition. But why we are getting 3 different diameter of circles? Because in first stage, we have allowed the consolidation. So the degree of a deformation in the first sample at 900 kPa and the amount of deformation in the second sample at 600 kPa. The amount of deformation in third sample at 200 kPa is different.
Means 2 different straight line for 2 different stages.
Yes. Okay. So that means at 200 kPa already it is consolidated. At 400 kPa it is consolidated. At 600 kPa it is consolidated. That means whatever the soil that is consolidated at 200 kPa, it will have a less resistance compared to what is the soil consolidated at 900 kPa. That's why when we are applying the deviatoric stress, that we are getting higher deviatoric stress for the soil which is consolidated at 900 kPa. Clear? So that's why you will get 3 circles of 3 different diameters. Clear? Then we will get similarly 3 different effective stress circles because pore water pressure development will be different. Clear? Because in the second stage now our pore water pressure is different. That's why we are getting 3 different circles. Now this I discussed normal consolidated clay. Same clay. In one condition we are saying normal consolidated, in other condition I am saying it is over consolidated. So in a normal consolidated clay, now you draw the tangent. what will happen? That a tangent will pass through the origin. What we said? It is clay. It is clay. Fine particles. There is a bonding. But from the results, what we are getting?
C0.
C0. Clear? Why C is 0? That I will discuss after few slides. Okay. Next, I will discuss over consolidated soil. Over consolidated soil means now what I am doing, I have applied confined pressure 900 kPa. I consolidated the soil at a 900 kPa. Then what will do? Unloading. Now I am removing that consolidation is there. Clear? Now what will happen? That drainage valve will be closed. Now that sail pressure I am decreasing. From 600 kPa I reduce to 800 kPa or 600 kPa. Already it has subjected to 900 kPa. But I reduced it to 600 kPa.
Both the condition valve is closed only.
Yeah. Remains closed. Okay. Only because that state of soil should sell. State of soil should sell. Only I am changing the confined pressure. Clear? So after removing this to 600 kPa, now I will do the test. Now the soil is in over consolidated because earlier it has subjected 900 kPa. The current state is in 600 kPa. So over consolidation ratio, that is 900 divided by 600 kPa, 1.5. Clear? So now I will do the test. Clear? When I will do the test, then what I will get? I will get one deviatoric stress. Now I will another sample. I have consolidated to 900 kPa. I reduced it to 300 kPa. Now over consolidation ratio is 3. From 300 kPa, now I will start the test. Clear? Then what will happen? I will get another deviatoric stress. That will be less than that point. Then I will reduce it to 100 kPa like that. Clear? So there I have shown over consolidation ratio I have written for different condition. Okay. So for that we are getting different circles. Clear? Now in this case over consolidated soil, you see when you draw the tangent, we will get both cohesion intercept and phi. Clear? Achha. One more thing. In previous case, in this case, effective stress circle is on the left side of the total stress circle. That means what it indicates? Effective stress is less than the total stress. Total effective stress equal to total stress minus effective stress. That means that pore water pressure is positive. Clear? But when it is over consolidated soil, that pore water pressure will get negative. There will be suction. Means now what we are considering that pore pressure measurement pi. Clear? This is the level. So in normal consolidation soil, from the normal level it is above, positive pore water pressure. When it is over consolidation soil, we will get below it. This is our negative pressure. Some suction is developed inside that soil. So that's why you will see that the effective stress circle in some cases you will see that is the right side of the regular circle. What the behavior, how it is changing, depending upon our over consolidation ratio. So that also affects our shear strength parameters C and phi. Next, this part, pore pressure development in the right side also. Okay, so because generally we are considering this is loose sand behavior is similar to normal consolidated clay, and this dense sand behavior is similar to our over consolidated clay. So you see any loose sand or that if I consider normal consolidated clay, you will get positive pore water pressure from the beginning. You see upper side is positive, lower side is negative. If it's a over consolidated clay or it is a dense sand, initially there will be positive pore water pressure. Why that happens? Because when we are applying the force, okay, so the particles or water cannot move out. Okay. Since water is not able to move out from that soil particle, so what will happen? They will try to, soil particles are there, clear. Now they will try to pull the particles, but they are not able. What the point? Now, there are two particles are there, inside water is there. So when we are applying load, all load is carried by the water. Now water will have a tendency to find the path, but already drainage path is closed. So what will happen? They will try to move, but water is not able to move. That means those particles, that water in between those two particles, those water will try to tends to force these particles, but able to, and particles cannot move because it is confined. So these particles will give positive pore water pressure in case of a normal consolidated clay. In over consolidated clay, it is opposite. Clear? What will happen in that case? That water, okay, that tension is developed. Clear? That particles, what will happen? They will try to move away from each other. Then tension will be developed. That's why negative pore water pressure is developed. If it is a dense sand or the over consolidated. Now consolidated drain test. Okay, in consolidation drain test, what happen? First we are consolidating, drainage is open. Second stage, when we are applying the deviatoric stress, drainage valve is open. Clear? Now this test generally takes about 1 month. One sample will take 1 month. To saturate the sample, it will take minimum 4-5 days. To consolidation, it will take 1 week. Then for application of a deviatoric stress up to failure, it will take 10 days. Why? Now see, in a UU test, suppose we are applying 100 kPa deviatoric stress. What will happen? We will apply at 10 kPa per minute. Within 10 minutes, test will be finished. In consolidated drain test, I will apply 0.1 kPa per minute. Why? Means to simulate the field condition. Means if I apply 0.1 kPa, what will be pore water pressure development? 0.1 kPa if it is undrained, if water is not dissipated, it is 0.1 kPa. 0.1 kPa is very negligible amount. That will not cause any harm to the soil. So gradually we are applying 0.1 in every 1 minute. So there will be no development of a pore water pressure throughout the test. There is no chance of a death. Means water is gradually draining out, but there is no development of a pore water pressure. Why? Because our rate of loading is very less. Clear? That's why it is we are saying consolidated drain test. That's why whether it is a total stress or whether it is effective stress, both is same. We will get only one parameter, total stress or effective stress. But in CU test, you will get total stress parameter, effective stress parameter. In UU, we will get only total stress parameter because we cannot draw effective stress circles. That cohesion is 0. That comes from the critical state concept. Okay, that I am not going. What happens when we say it is a critical state? Now, beyond a certain strain value, clear, that stress remains constant. So the point from where there is no change in stress, but it is continuously deforming. That point is the critical state. Stress remains constant, but material is straining. Okay, that is our critical state. And in a critical state, what happens? That bonding between the particles breaks down. Only there is friction developed. Whatever resistance we will get, that is due to friction. That bonding between particles breaks down. That is one theory. Okay, so that's why in a normal consolidated clay, why that we are getting from this. If it is over consolidated clay, its behavior will be brittle behavior. And when I am drawing the most stress circle, I am taking the peak stress. At peak stress, both cohesion and phi is there. But at a residual stress, your C will be 0 because bonding between the particles breaks down.
Then what is correct? What we have to consider? That the residual stress.
Yeah. Now, if you are going for conservative design or you are going for economical design. If you are going conservative design, if I consider the residual stress, I will get less strength, less resistance. If I go economical and I know my strain level cannot be more than that peak failure. my strain level cannot be more than 5%. And within 5%, I am getting the peak stress. Then I will consider that peak stress. Now it depends upon what is your level of strain you are considering for the design. Because my peak failure is coming after 5%. Then consider that. If my peak failure is coming before 5%, but my strain level is 5%, then consider the residual stress for safety. And you know, throughout my structure life, it can't exceed 5%. Why I will go on economical design? I will take high strength, peak strength.
By considering both C and Y.
Yes, sure. So these are the some
I
insights.
think it is economical to consider both C and Y.
Depends upon your structure, what is your strain level. That is also important.
It should come under from 5%.
Yes, means that you have to do the test. So my strain level is 5%. So within 5%, whether that peak level is coming or beyond 5%, then I can take the decision. Okay, huh? So thank you.
Sir, 2-3 questions, sir.
Okay. I think okay, sir. 1 hour I took. Because this is actually
Sir, for any structure, whether it is plant structure, whether it is any infrastructure project or any building structure, we are just first initial stage is soil investigation, sir. So where we decide the depth of the borehole, let us say 25 or 30 meters.
yes.
Now at that time, how to plan the laboratory test, these 3 type of tests, CU, CD and UU. Now initial stage we don't know anything. So what schedule we have to give them that this test only we want to do, for which test we should follow to use the C5 parameter in bearing capacity calculation.
Yeah.
That is first question, sir.
Yes. So what will happen? First of all, you will do one borehole. You will get one approximate idea. Clear? From borehole data, you will get approximate idea. Now what is the strata? Clear?
Yeah.
Then you know what is your type of structure.
Yeah.
Now from strata you come to know it is clay type soil or it is fully sandy type soil. Okay. From that now you will get one idea. No, my structure is a heavy structure. Okay. But its construction takes lots of time and it is clay type soil. Got the point?
Yeah.
So then you try for C.
C for clay.
Clay. Okay.
Let us say initial depth of 5 meters is continuous clay then.
Clay.
Then we are going to put
Because you need the consolidation parameters.
Okay.
In addition to triaxial, you have to do the consolidation test must.
Okay.
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 Now suppose sand is there. Clear?
Yeah. For 5 meters, let us say sand is.
That's why in some clients they are making, because projects, flexibility. Means they can change the requirement or test type during borehole. Suppose you now got, that's why they have kept some additional amount. Like that. Okay. So if this type of soil comes, then you have to go for this test. If this type of soil comes, then you have to go for this type of soil.
Okay.
Clear?
So that we have to decide later on only after
Yes.
doing one borehole or 3-5 boreholes.
Yes.
Wherever the soil occurs.
Otherwise,
So for
if
sandy
for
soil-
optimizing, you can do some tests under CU, some tests under CD.
So for if sandy soil, we have to go with CD only, sir.
No, that depends upon what is your type of structure and whether if it's fine particles. Suppose sand or particles are very fine, its behavior will be similar to clay. I am telling you, I will not quote that I am associated with one tailings. That particle size is just like clay and silt. Its behavior is sand-like. It is if you put it by hand, you will not feel any sticky type nature.
No, sir, but from grain size analysis, we come to know, na, sir, that 90% is sand and 10% silt and clay.
Because in another location, that tailings are clay type. Cohesion is very sticky type. Because initially, let's say by experience, we will feel whether there is a cohesion type available or not. If it is sticky type, means it indicates it is some bonding is between the particles. If it is not non-sticky nature, means it is granular type. But what it indicates, it is very fine. Its particle size is less than sand size. Then now it is difficult. That's why Sato that tailings It is difficult to
No, sir, I'm
comprehend.
not talking about tailing. I'm talking about other structure.
Yes, yes,
where if
yeah.
I am getting sand, 80%, 90% sand, which test should I follow in the laboratory?
You go for a drain test,
CD.
CD test, okay. Then you see what is your loading rate. Whether it is rate of loading will be very fast or rate of loading is very less. Your construction duration.
But sir, as you mentioned, CD test takes 1 month, you said, right?
Yes. And I am telling
No
you,
client is ready to wait for 1 month to
I am
do the
telling
structure.
you,
They are saying
if you are giving
immediately
any
submit the
sample
soil report.
to any agency, they will manipulate the result for CD test. They can't do 1 month.
Yeah, nobody. Even client doesn't wait for 1 month.
Yes,
sir.
yes.
They don't want to wait. They said immediately submit the report, do the foundation design, we want to start the
Start
construction
the construction.
or the execution.
Okay.
So for 1 month they are not ready to wait.
That's why we are using factor of safety. Now
For
look,
all these things.
if your factor of safety is required 2, you see in most of the cases they are multiplying 4. Because I don't know exactly what is it.
No, but in calculation we are taking 2.5 as per code, sir.
As per code,
Yeah.
but you see, in between they will make some manipulation. Manipulation, there must be some manipulation.
And sir, let us say if sandy clay is there, mixture of sand is 40%, clay is 60%. Then we will go with UU test only, no sir?
Yes, sand clay. No,
Sand clay, mixture is there, then
mixture is there.
which test do,
But
sir?
if
For
it,
C5.
there's in that location, there you think there's no possibility of your quick loading condition. Rate of loading is not so high. Then you go for CU and CD.
CU only.
Like this, one doubt.
You test only if you come to know your
Pure
during stage of construction, it is in an unconsolidated stage.
And pure clay.
Yeah.
That will be for pure clay.
Yeah. Oh,
Okay.
From these 3 conditions, unconsolidated undrained, consolidated drained, and consolidated undrained, we only get effective stress in only one condition. That is a drain and
Consolidated on drain, you will get both effective and total. Consolidated drain, both are same. Whether effective or total, both are same. Clear? And in unconsolidated on drain, only will get a total stress parameters. And that total stress parameters is used for this on drain shear strain. That we are determining stability, short-term stability, short-term.
Please repeat it from the beginning.
One is UU, okay, that you will get only total stress parameters. Clear? CUU 50. Then another is CU, consolidated on. You will get both total stress parameters, effective stress parameters. Third is the consolidated drain. We will get total and effective, both are same. There is no difference. Clear? Then
Because pore water pressure is 0.
yeah, 0. Throughout the test it will be 0.
So most of the cases we consider while designing the draining dam, consolidated drained.
Consolidated, we are considering on drain condition, UU condition.
UU condition.
Short term, there are 2 conditions. When we are determining that the slope stabilities are discussed, that short term stability and the long term stability. In long term, we are saying factor of safety 1.5. There we are considering drain parameters. And if it is short term, then we are using the total stress parameter. Only on drain shear strain, we are considering 50. Or any? Okay.
Okay, thank you very much. We can have further discussion in the team during tea. So, thank you, sir. That was a really insightful lecture, and I've known Professor Sahu from a very long time. Like I've been following your work, but it's first time that I met him here. I've been to IT Kanpur also, but I could not get the opportunity to meet him. So thank you very much. As a token of love, we'd like to offer something to you. I'll request Panda sir to please. Sir, please.
इधर सर very good, like the basic concept, but again these are mostly coming from the soil mechanics point of view, but when we go to the tailings we have to understand the tailings, then you see that all this concept is applicable or not. So that's why for the tailings it will vary from site to site, and in a particular site also it may vary from dam to dam. how we are making the progress. So definitely next 2 days we will mostly focus on the case histories, and there we will know more and more about the application of these soil mechanics principles. But this is the concept based on which we will develop our knowledge base.
Thank you. So, thank you very
That's
much
how
for
is my
coming.
teacher. Okay, I have learned all this from him.
So he agreed to give a presentation. Actually, we could have also, I mean, what I am planning now, in the afternoon, we will have like a panel discussion. So I am inviting Professor Sahu, and yesterday Dr. Partha Mishra from Australia also I am requesting him to join. Our expert Dr. Panda will be also there, and also I am calling one from TC, Subhranshu Raut, and one from SRK, Dr. Akila. So that time what will, because we have got since morning, I am looking at there are so many queries, so we'll take different aspects. I mean, you see, mostly when you are in one client, owner side, so you have got different challenges. You are not doing design, but you have to find out a best designer. You are not executing, but you have to find out the execution. That means, and also during operation, and if post closure and so on, everything you have to look after. So this course, so when in that discussion, the panel will also discuss about the different problems which we, suppose say now we will follow the GISTM or ICMM. So what are the problems they are in? They are voluminous work. I mean, you cannot read everything being in a job with doing so much of executive work. So there we will discuss, and another aspect what it will be there also. So when we are saying that, what I will do, I will just present around 30 minutes or 15-20 minutes, what the basic principle that ICMM or that GISTM is saying. So then you say the problems happening. Like in this case also, where we are discussing about technical. So in the technical, like you have some issue, maybe you are not able to identify now, but after 3 days, I think you might have identified certain things. So that will also come forward. Like when we were talking morning, you were talking about seismic, earthquake. So before that Bhuj earthquake, 2001, I had experienced that time at the 7th floor in AIIMS Bhubaneswar, Delhi. So it was shaking, that was 26 January.
Yeah.
26 January, previous day there was a rehearsal. So the vehicles were going, and because when there is function, they used to come and do the rehearsal. And so what the rehearsal now, maybe suppose any attacks come, so that's why they are doing rehearsal. And morning 8 o'clock, there is lots of sound and vibration. We thought something has happened. So that means then we came to know that in the news that Bhuj, so things happened. You know, Bhuj was only they put in zone 3. After 2001, it became zone 5.
No.
So you don't know. So that's why what Dr. Ponda said, is so that what now in our campus one observatory is there, seismic observatory. In and around whatever the small, vibrations or shocks are happening, we are measuring it. So similarly, Government of Geological Society has put in different region. If you go to Talcher region, there is a government engineering college, Sarang, there is also they have put one. So that is below 30 meter. So they are observing every day. So then after certain point they will come, maybe new things are coming up. So then they will find out there is a fault, geology will come. Because that is what you are saying 1,000 years. For 5,000 years, geology people say it is a new. 5,000 is new. Only when it is more than 10,000 or 3 crores of age, they will say it is stable. That is Jurassic, or so many ages are there. So that way, so here only we are talking about that region which may not have experience, but they expect it may happen. And that is through observation they are just justifying. It could happen. So why otherwise measuring all these things? So that is one. And what is the problem in water? Suppose a dam. I have got a control. Immediately suppose I feel something is happening, I will decant it. Can you do that in waste telling facilities? You cannot decant. You have no choice. Even if everything, what is happening now, rainy season comes, they will open up the gate. So what will be released? But telling them you have no choice. So that's why in the very first slide when you are showing the live period, so that is what you have mentioned. You have to wait for 500 years also. Because anything that time it happens also, again it will be catastrophic. So that's why it needs lots of attention. It's not like in water time, so immediately I relieve it. I found some problem, I relieve it and revamp. Over. But that you cannot do in telling them. So all these things keeping in mind, so we are not able to feel it because most of we are dealing now fly ash. So far the government has said that it may not be that hazardous. So we are able to dump at different places. But again also, last week one DGMS people, one that scientist, he asked, are you sure when you are dumping it? I mean, not sure, but only they have no choice. So we have to fill in the dump, mine dumps and so on, but we don't know what will happen in future. After 200 years may create a problem. Sometimes you feel that whatever ancestors have done has become a liability for us, and something we say it has become a resource for us. So unless we do a proper judgment, that is what the sustainability and what Dr. Pandya is trying to emphasize again and again. This environmental aspect, we cannot just think about the today. We have to think about the future. Whatever we are building, it should be an asset, not a liability in future generation. Then they'll start scolding us that they have left there something which we are not able to manage. So thank you very much. We'll now go for the tea and then we'll start the next session.